Hey, everybody. Not sure if you can hear me or not. Hoping that you can. We're just going to wait a minute. We're just getting a bunch of people are joining right now, so we're just trying to make sure. Excellent. Thank you, Michael. We're just trying to make sure that everybody gets on board here so we can get started in just a minute. And Beak, I'll let you let me know when we should get going here. All right. I've been given the green light. So I want to welcome everybody here to our webinar. I am not going to take very much time in what I am going to have to say. I think that we all know why we're here. You guys are attending this because you saw something that sparked your interest, and that something has to do with your old TDM network. I have been in primarily the TDM network game myself for more than 25 years, so I'm very familiar with your pain. I spent a lot of time at Tel Labs selling big cross-connect systems, which I'm sure you're familiar with, and maybe many of you are still dealing with. So what we're going to talk about here today is how we can convert those TDM systems, maintain that TDM revenue, actually potentially increase that TDM revenue by avoiding SLA issues and whatnot. And I also want to tell you briefly, you can see when this thing was sent out, this invite, that Tejas Networks, hopefully most of you are familiar with us, but I think many more of you here in the US are probably familiar with 1finity, or I should say more familiar with Fujitsu. The 1finity name is relatively new. But while Tejas has great expertise in circuit emulation and the product, and has a tremendous product, we know that this is really a large process. And we came to 1finity because they have tremendous experience in their professional services group with migrating traffic, with modernizing offices, condensing old TDM systems. So really no one better than them at doing this. So we have a two-part session here. Narendra Rajwanshi, who is our group manager for sales, I've been working with him for many years. He knows more about this product and more about what's going on in these TDM networks than pretty much anybody I know. And then we also have Brian James, in addition, who is the service manager for 1finity, and again, knows tremendous amounts about what this involves from the services side, has been doing this for many years. So I'm going to go ahead and get to the smart people here and let Narendra take over and tell you a little bit about what we're talking about. And then he's going to hand it off to Brian. Then we're going to wrap up with some Q&A. So if you guys have some questions, type them in and we'll get to them at the end. So thank you so much. Narendra, take it over.
Thanks, Rick, for the introduction. Let me share my screen and let me know if it is visible to all of us. So I hope my screen is visible to all of us.
Yeah.
Okay. So good morning, afternoon, evening, everyone. So today we are here to talk about transformation of the legacy TDM networks with a new packet-based technology, Ethernet or MPLS. This transformation is also being called as network modernization or NetMod in the subsequent talks that we are going to have. Now, before taking you through the challenges of the legacy TDM networks and the applications where this transformation fits in, the available solutions, let me take you right through into a transformation that we have recently done along with our partner 1finity in one of our customers in US. So this is an actual picture of a central office for the customer. The equipment that you see here highlighted in the blue box is a DAX. So DAX is a digital access cross-connect system, which basically interconnects TDM interfaces, DS1, DS3, EC1, OCM, SONET interfaces between the various TDM, legacy TDM devices, or even a local voice switch, a legacy voice switch, which takes in DS3 or EC1s. Now, this is the transformation. This entire DAX, which is a 3 bays of equipment, was replaced by our two-use shelves. So that is the transformation we are talking about. And what does that mean? Basically is 3 bays of equipment replaced with just 4U of space, a lot of space savings as we see, 3 kilowatts of power being replaced by just 500-watt new power consumption. So that right away is a lot of power saving, which is the real, value in this transformation. The space could be central office's own, or it could be co-located. Co-located will have more value of the savings. So now let me take you to the challenges of the legacy TDM networks. So as we all know, the main challenge of the legacy TDM networks is the discontinued hardware, manufacturing discontinued, end of life, no spares or replacement parts available. The legacy TDM equipment, as we saw in one of the examples, are very bulky and high power consuming, not eco-friendly, of course, having a high carbon footprint for your corporates. There is absolutely no vendor support or very expensive support from third-party providers, very expensive spares from the gray market. So in order to maintain these legacy networks, the cost is rising every year for the support and even for getting the spares from the market. And also there's a scarcity of the in-house technical expertise to maintain these equipments and networks. So these are typical challenges that all the operators see, as we have known. Now let's talk about the transformation, how to transform these legacy networks to a new packet technology. So it's a 4-step transformation strategy that we have chalked out and worked well in our earlier transformations that we have done. So we start with, of course, the data mining from the existing TDM systems, or it could be through the inventory databases, like OSS systems or any other systems which hold the data of all the services that are actually working. So we don't need to replace the exact hardware with the new hardware for all the ports. So we are identifying only the services which needs to be brought into the new platform. And then the network build, of course. So build only what you need with a 10-20% buffer, which is always the case in any telecom scenario, in case some new additions to be made or in case some things missed out in the data mining. The third important step is the migration, which is very crucial, how to migrate the services endpoints from the legacy system to the new one. And finally, turning off the legacy systems, dismantle all the equipment to save the space and power. And they can also be used as spares for other parts of the network which are still working. So this is the transformation strategy that we follow and have done successfully in the past. Now, to start this transformation, there's a question of the choice of technology that we should adopt. So one option is to build a new TDM infrastructure, which is OTN based. So that can carry, of course, the SONET interfaces of the past and also can carry Ethernet services as well. However, there's a challenge in this that it needs a completely new build out, a new fiber overlay, a new technology, new training. It is costly and time consuming. The other option is to go with the packet technology, okay, which is Ethernet or IP MPLS, which is an existing technology. All the operators are very well versed with it. It is ubiquitously available, can be up to the customer premise also. And of course, all the operators will have in-house expertise. So it is an inexpensive and the fastest way to do this network modernization. So that is our choice of technology for the future. And not only that, the same infrastructure can carry Ethernet services when slowly the TDM services fade out or get converted into Ethernet itself. Let's look into some of the applications where this transformation applies. So one is a typical SONET ring that many of us would be familiar with. Every operator must have that, OC 12, 48, or 192 rings. Also having a DAX at the central office and then doing the interconnects to other SONET providers or a switch sitting at the central office. Now this can be replaced by the new Ethernet platform. Okay, so basically we create a 10 gig packet ring, or it can be multiples of 10 gig also, or 100 gig. Now this becomes like a Metro Ethernet network, and which is able to carry TDM also on it through the circuit emulation technology. So you can carry all your legacy TDM services from the network in the ring up to your central office. And also at the central office, the DAX can also be replaced by adding some more nodes at the central office. So this is one of the typical applications to replace the SONET and the DAX legacy systems from the network. Other interesting application would be to reduce the leased bandwidth cost. If, as an operator, you are using third-party TDM lease lines, which are again getting very expensive every year because those operators have to also maintain their TDM networks. But that can be simply achieved by having two bookended new nodes, TDM over packet nodes, and having a shared leased Ethernet bandwidth between the two. So not TDM now, but Ethernet bandwidth. So which is very inexpensive. And then interconnecting through the SONET nodes and releasing the TDM lease bandwidth. So this immediately reduces your recurring cost of the lease bandwidth. So that is a very neat application to save a lot of money immediately. And eventually the SONET nodes also can be replaced later. So these are the typical applications for this kind of transformation. Now for the actual migration, yeah, there are obviously challenges. There are questions how to go about this migration. So one of the simplest approach to do a SONET ring replacement is to build an overlay network with a separate pair of fiber with the TDM over packet nodes, creating a 10 gig ring or a 100 gig ring, migrating the endpoint services onto these nodes slowly, and then finally ripping out the legacy network. Okay, so this is how it will look in the final stage. Now this has a challenge that it needs a separate build out, a complete ring has to be made, a separate pair of fiber needed. The other approach for migration is much faster and inexpensive. So we can start off with any two nodes on the network and hook it up onto the IP MPLS cloud, assuming the IP MPLS is available at those two locations, and then migrating the services off to this new platform. And then slowly we can add more nodes in the network. So we don't have to depend on a completely new fiber pair. And this can be migrated at ease, one node at a time. And then eventually the legacy network goes out. So these are the two approaches that we have seen, and both have been applied in different operators. The other important aspect doing this migration, especially when IP MPLS cloud comes into play, is the synchronization. How do we synchronize the two nodes carrying the TDM traffic over packet? So at least one of the node needs to have a primary reference clock, which is represented here. Let's say one of the node. And if both the nodes are connected directly to fiber, we can transport SYNC protocol to synchronize the other node. So that is a synchronous Ethernet protocol. And if there is an IP MPLS cloud in between, both the endpoints need to be synced through the external clock, a primary reference source. And then a differential clock recovery algorithm runs to synchronize the packets in the sequence. So that is a DCR algorithm. Now, what happens if we don't have the PRC clock at all the endpoints? So one of the node gets synced to the primary reference source. Other end is not. In that case, we can run an adaptive clock recovery protocol. So it doesn't need the external clock at other end, but still it will be able to decipher the packets in the same sequence. So this is how synchronization approaches are done. And management is available in-band and out-band also, the standard approaches for managing the nodes through the in-band VLAN going through the cloud, or it can be out-of-band management as well. Now let's see the solutions available to achieve this transformation. So from Tejas portfolio, this is the entire package of the solution available. Starting from the top, it is TJ1400P, a 1U pizza box factory-fitted configuration, which can uplink multiple 10 gigs. And it can do up to 16 DS1s and few OC3s. So this is primarily architected for the edge applications, customer premise application. Then we have the full redundant and modular chassis 2U 1407, which can have much more capacity and can aggregate a lot of 10 gig rings, and hence the DS1 and DS3 traffics from the network. If I just project the scalability number of this 2U shelf, a single 2U shelf can aggregate up to 5,376 DS1s, 1+1 protected in OC48s. So we can gather up to 5,000 plus DS1s from the network and drop it on the OC48s here. And likewise, you see other numbers in terms of the DS3s and DS1s that we can do. To complement these two, we also have a DS0 grooming mux, which can cross-connect up to 80 T1s, all broken down into DS0s, around 1920 DS0s cross-connected to each other. So this is also a highly scalable unit. And all of this managed through a single pane manager. Let's talk about the network manager here. So this is how it looks. It is all graphical based, no CLI, all point and click provisioning. The configuration is all wizard driven, so chances of errors are pretty less. There's an automation also built in to find the paths between two nodes in the network automatically. We can pre-plan the services. Everything is point and click, as I said. And a full suite of operations and maintenance tools are available to troubleshoot the network, to do performance management, backups, report generations, etc. So this is what I had for the, the applications and the solutions that we do. Yeah, that's it, Rick, from my side. I think we can hand it over to Brian.
Okay, that'd be great.
Thank you. Thank you all.
Thank you, Narendra.
All right.
Just a quick reminder to everybody, Brian is the service manager at 1finity and has many, many years experience and lots of knowledge about how the traffic that Narendra was talking about actually gets migrated from the old systems onto the new. So that's what he's going to talk a little bit about, and I'm going to hand it over to him. Go ahead, Brian.
All right. Thanks, Rick. Everybody hear me okay?
Yes.
All right, great. Hey, appreciate everybody making time today. I know everybody's busy, whether you're in the first thing in the morning, midday, or late in the evening. So thank you so much for taking some time out to listen to what we have to offer here in partnership with Tejas. Again, Brian James, Services Sales Manager. And I want to talk today about the network optimization portfolio that we have from a services perspective at 1finity. And again, we are a Fujitsu company. Just a brief discussion around what 1finity brings to our clients from a multi-vendor service portfolio perspective. We've got multiple service areas that we focus on: design, build, operate, maintain, transformation, and then we have a value add managed service. So we also have some advisory services. Our design build is more your traditional EF&I, multi-vendor solution architecture, master network integrator, EF&I engineering, installation, turn up and test from an OSP, ISP perspective, edge to core enclosures, some factory pre-configurations, and all of this is umbrelled with program management. Operate and maintain, that's our NOC services. We have a world-class NOC in Richardson, Texas that we utilize. Managed network services, software operation, upgrades, provisioning, pre-owned CPO equipment, break fix opportunities, etc. Transformation is what we'll be talking about here today, the NetMod service. We also have traffic migration and EMS transformation. Our value add services, value add managed services, white labeled managed network service approach, SD-WAN type solutions, fiber assurance. So we've got some really, really cool software packages that are AI generated that we could talk about, but that's not the focus here today. Just in general, 65 plus OEM operation systems supported, 500 plus multi-vendor projects completed in 2024, 850 large scale such customers served, 100% deployed on schedule, on time. And then our net promoter score is 75.41. What is that?
Just a minute, Brian, are you sharing the screen?
I am, yes.
Is everyone able to see? I wasn't.
Yeah, I think we're just able to see your face.
Oh, you just can't see. You can't see my presentation?
Nope, not right now.
Yeah.
All right, let me try again. Hang on.
Man,
sorry, guys.
Might need to jump in.
Yes. No.
All right. How about now?
Yes.
All right. Technical glitch. All right, there we go. Sorry about that.
Perfect.
Again, net promoter score. What is a net promoter score? That's a customer loyalty and satisfaction marketing research metric that is utilized to measure the likelihood of a customer recommending a company's services and products. again, 75.4. What is that? That is the 75 and above is considered world-class or exceptional product and services from said customer from said customers about 1finity. So we are highly recommended and from our clients that we service. Today, we want to talk about the network optimization services that we partner with Tejas on. Again, our AKA NetMod service. It's a four-phased approach. Miranda went through some of those phases as well in the very beginning of his presentation. A little bit more deeper dive. We start off with network analysis, which is the analysis of systems or networks for optimal migration strategy. We do it via remote. We do it remote via records. The second phase of that is network discovery, where we take what we find in the engineering analysis and the generation of the network audit sheets with all the types of different circuits. That's an on-site survey for validation. So what we're doing here is we're going on site and physically validating at the equipment what the records say, making sure that they match or don't match, and then come up with a solution to make a match so we can start planning the overall migration. And that's the third step is the network analysis, which is the engineering, the migration of the engineering migration, the generation of the cut sheets, the circuit maps. Again, this is remote migration engineering that we focus on working through the first two steps and getting a plan put together before we actually go out and do phase 4, which is the network migration. Churn analysis for the migration we come up with an idea about how that works. We create the provisioning scripts, and then we on site we execute the migration plan and do the physical migration of the circuits to the new next gen platform and prep everything for removal that is being decommissioned. In order to do this, we've been doing this a long time with Fujitsu, 1finity, and we have come up with a whole tool bag or toolbox of software tools that our NetMod engineers use. Our data scientists work very closely with our network integration engineers in the field, understanding what they're doing, what they're up against, the data, the amounts of data that they're crunching, and come up with automated tools that make that a simpler task. So all these tools are utilized in one of the four migration phases that we just went over. The INDA tool is an audit and network tool for churn analysis that helps crunch thousands of lines of data, circuit A to Z locations. Instead of taking months from a manual perspective, they do it in minutes, actually. The ERIP tool automates the retire in place for power saving. So we're looking at the first two phases of the process and coming up with, okay, what are the low-hanging fruit, if you will. What can be removed right away? What are zero fill circuits? What are not zero fill circuits? And we come up with a detailed list of data that shows what can be removed and what can't be removed without some type of migration. Again, that is something that has been done manually in the past, and we can do it via automation that takes literally 2-3 minutes as opposed to 2-3 weeks. Another application that we utilize is the ITEQ, which is Turks data analysis. We can download your Turks data into our tool and bump that up against what we found in the field and come up with a data list that shows again the zero fill, the circuits that may have traffic on them that need to be further investigated, or circuits that we know have traffic on them that will continue down the path of the migration engineering. We also have a stitching tool where we can take multiple sources. That's the IWSM tool. Take multiple sources of data from multiple different devices, put them all into the IWSM tool, and stitch them together and come up with a mapping service that shows where the circuits could be mapped to and how we could migrate those services over. So with 1finity's expert network migration engineers using these tools, we're cutting the overall automation, we're cutting the overall process with automation from months to days or weeks. To show how all this, how some of these tools work together. So the engineering analysis tool is the ERIP tool that we talked about just briefly a minute ago, and that is the tool that goes in and looks at the power savings. The ITEQ tool, then the IDSO tool. So that's all in the very first phase of the migration that we are looking at. The network discovery, automates certain aspects of the network and discovery, the OSS data reconciliation. We utilize the IWSM tool, which again, that IWSM tool is the intelligent wavelength stitching tool. The IDFS tool is the discrepancy report. It pulls the discrepancies are circuits that are showing that are showing active traffic and not showing active traffic, and we can use this tool to verify with our engineering analysis phase what's working, what is true and what is not true. The goal here is to end up with the integration and the migration with zero trouble tickets generated, which is making sure that your network is completely protected during this migration phase. The network analysis and network migration tool, the IOCR, the IWCM, and the iView tools are utilized quite a bit. The iView tool, for example, stitches maps. If we're working with FlashWave or specifically Fujitsu gear, it'll map those wavelengths across the networks and show our engineers how to develop the cut sheets to migrate off of said platform to new platform. The IOCR tool is another tool that our team uses that converts the written records and screenshots into usable data, so we can upload written records or screenshots, put them into this tool, and it will convert them into usable data that we can work provisioning our scripts or scripts for mops or creating our cut sheets and templates. And the last phase that I did not talk about in the very beginning was the inventory system update. That's the OSS record. So as you migrate from old to new, using the Tejas equipment, the OSS records will obviously need to be updated. We've got a couple of tools that automate that to help get those records in upstanding order based on the red lines the migrations that we did, to have your records at this point in time 100% accurate. And now as time goes on, we can continue to update those records to keep them as accurate as possible. So the whole idea of these using our 4 phases and our tools is to reduce the level of manual effort required to complete these tasks, shortening the window of migrations. So yeah, quicker, more accurate quotes, higher quality results, quicker service rollout, faster response to your needs, and more efficient migrations are all benefits that we are seeing with our 1finity NetMod intelligent tools. And again, all these are internal tools. There's something that they're proprietary. We don't sell these outside of 1finity. Our engineers use these tools to their benefit to show the different, to be a differentiator basically in the services that we provide from a migration perspective. And as everybody knows, the migrations are very, very complex. There's lots of data, lots of circuits, and the end goal is to make sure that we make this transition from old to new with no trouble tickets generated. So we are the go-to company for network modernization. We've got multiple clients. We've done over 1,800 completed projects since 2014, 4.5 million circuits migrated. Vendor platforms, we have experience in 52 plus vendor platforms. So it's not just 1finity or Fujitsu FlashWave gear. We've got multi-vendor capabilities. You just kind of go down the list of Ciena, Cisco, Alcatel, Nokia, et cetera. We have experience in most of the major platforms. We've got dedicated NetMod resources, meaning they are our network integration engineers that all they do is NetMod migrations for our different clients. We've got a tried and true process as well. One of the things that 1finity shines with is continuous improvement. As our engineers come out and go out and they do these migrations, they feed the information back to our data scientists. So our data scientists can look and see what the pain points were, what the roadblocks were, and update our tools and processes to improve the overall product and service. Our live traffic, we're live traffic migration experts. So most everything we do is a live traffic. So again, we got to be very meticulous and careful with our process, our cut sheets, our migrations, our planning. So when we go out and do the migrations, again, zero trouble tickets is the goal. And just wanted to throw the net promoter score out there one more time because again, 75 is considered a world-class and exceptional customer service. And just to wrap up with one example of network optimization that we have done for a client, it was with our FlashWave 4500 gear, the Fujitsu FlashWave 4500, and using the Tejas 1400 CEM equipment. You can kind of see that we had 100. You can see here we had 173 shelves that we were removing, and about 18 amps per shelf. That translated into about 100 amps with or 100 shelves with about 7.3 amps per shelf. So you went from over 3,000 amps down to a total of 730. So over 3,000 amps saved using the Tejas equipment to do the migration. Power cost savings, in this case, it was 43 cents per kilowatt, and the cooling power is down. Was 33% of the direct cost there. The direct power is from the 4500 to the Tejas 1400. You can see the difference there, the cooling estimate and the total. So going from the FlashWave 4500 to the TDM Tejas 1400. You can see the savings there. The direct power savings, $700K, cooling estimate $250K, and the total of over $1 million in savings just in the power costs. So you combine those savings together, and you got an estimated $1.2 million in savings from a power and HVAC cost savings. So that's quite significant savings from migrating off of X platform to the Tejas equipment. Some of the additional paths of potential cost savings that weren't included in the ROI schedule: gray market CPE sales. So anything we remove, we can review and look and see if there's a market for that equipment outside, and we can help get that equipment sold or positioned to sell. Spares management is another enhancement that we look at. You can replenish your spares within your company using the equipment that you've migrated off of. Real estate savings, as it was shown, it would go from a huge DAX rack lineup to 2 or 3 or 4 RU boxes. Troubleshooting for your technicians and truck rolls is greatly reduced. And you hit your green initiatives, your metrics for your green initiatives are met or exceeded. And note here, you have to basically understand what your replacement equipment power consumption is and do the math there to see what the actual ROI savings are. But on average, our estimated ROI is about 1.2 years. So your output, your cash outlay to do the migration and position the Tejas equipment is X, and over a period of 1.2 years, you'll recoup that, and the rest of that will be savings in the future. And that's kind of a brief summary of the network modernization service at 1finity. Appreciate you guys taking time and listening. Rick, back to you.
Thanks so much. Thank you so much, Brian. So we are going to be getting to questions momentarily. I just wanted to kind of summarize a little bit about what we're talking about at a very high level. So the technology that Tejas has developed, this is not brand new. That was just thrown out, although we continue to modify and just added a major feature in the last 6 months. But modernization from a circuit emulation standpoint has been somewhat stagnant up until this last couple of years. And now it is really taking off in a very big way. And there's 3 primary reasons. The 2 original reasons was that people thought TDM was simply going to go away. But what we have found, and I think what all of you have found, is that your TDM customers have continued to demand that service, even though you raise prices every year. They are not going away. That's number 1. Number 2, as you can see from Brian and Narendra's presentations, this is a very complex situation to deal with, and most of you all do not have the staff, frankly, and the expertise to do this, and so it has been almost fearful to try it. In addition to that, your staffs at most of the service providers that I'm dealing with have been skinny down, so it becomes very difficult to do this. The last point, which is a new point, is all of the new AI technology that's out there that helps service providers heal their networks more efficiently, optimize their networks more efficiently. These AI tools do not work over these old TDM networks. And so if you all are really going to modernize and optimize your network, this is the place that you need to start, is to get off of the old TDM at the edge and get it all onto Ethernet so that the AI stuff works. What we have done, the reason why we have partnered with 1finity, and this is a deep partnership, we've been working very, very closely together in the last year, is to provide a full service turnkey solution, because I've had conversations with service providers in the past where I've said, hey, we have a turnkey solution, and they've kind of laughed and said, yeah, my guys always have to be deeply involved in that. I can tell you, we're working with major service providers. They are providing us access to the sites and access to the data. And between our product and 1finity's expertise and service, we are able to migrate the traffic in a very efficient way. So having said that, I want to skip to questions. Ambika Manjanath, do we have questions in the queue at all?
Yes, Rick. So
looking at that.
There were a few which I've answered. Brian, I think you're open to comment on that as well from your perspective. They have, I think, been moved to the answered tab
Ah,
Yep, the one I saw. So I think it was from Michael. It's going to be a percentage of partially filled. Just depends on the size of the migration that we're doing and what we're migrating off of and to.
all right. I think we
Brian.
also, let's see, I got an answer here about, our question here about what happens to the Circuitum device as the number of DS1 and DS3 lines decline? Are we stranding the SEM device? And obviously I can let Narendra go into detail on that. But it's a great question. The number of TDM services, you know, they may be declining at some point, which is natural. But they are, you're able to replace those ports with Ethernet ports. Narendra, do you want to expand on that at all, or did that pretty clearly answer the question?
No, that, yeah, summarizes that. Yeah. So we can
And
replace
then,
them with Ethernet blades, and which can be used for new revenue services, carrying E-line, E-LAN, or E3 kind of services onto them. Yeah.
yeah. All right, and then I have one last one here, which is with regard to improving profitability when you need a capital investment. Obviously, you have to pay for equipment and services, so there's a cost to this. But that investment is really more than offset by the savings from the legacy TDM equipment. You know, obviously, most of this TDM, I would say all of it almost, that's in your network is either end of life or ND'd. So there's growing support costs if you can get it. You still have SLAs that you need to maintain, and if you have outages, that is quite difficult. It consumes a lot of space and power, and trying to find just you know, replacement cards and whatnot is very, very difficult and very cost consuming. We've seen cards that you know, maybe for example, like an old Cisco 15454 that might have been $1,000 or $2,000 card that's now $20,000 if you can find it on eBay. So there's a lot of cost savings here. If there's any other questions, I don't think there currently are. We would love for you all to follow up. If you do have any questions that come up, you can simply send them to SEM at Tejas Networks. I believe that was put into the chat. And for those of you who we know that are on here, we will, of course, follow up with you and get back to you to see if you need any further answers or information. Other than that, I will say thank you very much for your attendance, and we hope to see you and speak to you soon. Thank you very much for being here.
Thanks, Rick.
Thank you very much. Appreciate it, everybody.
Thanks, Brian.
Thanks, everyone.